Nice to see you.
Good to see you.
Okay, now let me tell you, these YouTube videos watched by children, by Turkish people, by people in Germany, in United States, very diverse, men, women, and somewhere in between, everyone watches. Therefore, we will try to kind of hit somewhere randomly in the middle, appeal to all of them. Therefore, I will ask you some questions and something that's related with your personal life, if you want to, as much as you want to tell us, and something about your professional life. And this is Mark Sykes, people. This is Edip Yuksel, Mark Sykes. We know each other by, really, I don't know why we know each other.
Because of an affinity of our personalities.
And we kept a friendship. That's so interesting. About 15 years ago at law school, 15,
Longer
16.
than that, it was probably, say,
95, 96, 96.
17 years
Yeah.
ago.
Wow.
Yeah, 17, 18 years ago.
Yeah. Too many years ago. In law school, both of us were mature. And there we, mature according to the age.
Yeah. Well, by comparison with the other law students.
Yes,
we're mature.
Anyway, he was already Ph.D. He was working in astronomy department here. Astronomy, whatever you call it.
Stewart Observatory.
Yeah. And now Mike is the president of Planetary Institute.
Planetary Science Institute. Yes.
Okay. PSI. The website is psi.edu. Edu, fantastic. Edu, psi.edu. Anyway, now we'll ask some questions. We'll talk about some of this world, and then we'll get out of this world and maybe solar system. And we don't want to go far away.
Go to your world.
And I met him in law school, imagine. He was PhD already in science, and then end up law school. And I end up in law school, which is, I was a lawbreaker, correct? A convict.
I'm not going to say nothing.
Okay. We had great experience, and we had, in fact, a class even from whom?
Jane Korn.
Oh, Korn!
Yes,
Korn!
yes.
You love that
and
one.
And Genghis Korn.
Yeah.
Her dog.
Yeah. Oh, God. We had very...
Yes, and Rehnquist on History of the Supreme Court.
Yeah, and one of my favorite class was... Bayer, what was her last name? She was teaching property class. She made me love the dullest class, I thought, and became my, she was a graduate of Yale, and she was looking at why there is this law, for example. And
I don't remember who that was. Been too long.
Yes. Adverse possession. Why we have this law? I was very interested with reasons. Okay, now. Can you tell me about yourself? What are you doing? How many scientists you have working for these? And
well, we've got, right now we have about 89 PhDs. We're in
89 PhDs?
Yes.
Okay.
All working in solar system exploration, involved with almost every NASA solar system mission. And people, they go around the world doing field work to look at sites that are similar, like the way things are on Mars and other places. They do basic research, theoretical type stuff. They're located in 20 states in the District of Columbia.
Okay.
And so it's a distributed. We have about a third of them here in Tucson, and then the rest are distributed around the country and some other parts of the world.
Which part of the world?
Oh, well, we have people in Ireland, the UK, France, Russia, Latvia, South Africa, Australia, and
international.
Yeah.
And he is a traveler. Basically, when I call him, usually he's not in Tucson.
Very true.
And then, but he's black.
Usually in DC.
He's a black hole in DC. He ends up in DC. He has two hats. One hat is the scientist hat. The other is a lawyer hat. Somehow that works.
Well, I don't practice law. I mean, I don't put food on the table as law. Okay. The other hat that I wear is his musician hat.
It was a surprise. Okay.
Okay. Cut.
No. We have to start with that.
Okay.
Okay. What is your voice? Is soprano, tenor? What is this?
Bass baritone.
baritone, or bass baritone, the lowest one.
Not bass, not basso profundo, but, but yeah, bass baritone.
Baritone,
So it's kind of in between bass and baritone.
Wow. Okay, now I have to listen to you. We have to. You know what?
You listen to me laugh.
He's incredible. Imagine he's also a member of opera, Arizona Opera.
Yeah.
Arizona Opera. He's a professional.
The chorus.
The chorus.
Coro.
Okay, I'm musically challenged. My English even is not that good.
No, I don't do solo. I don't do solo stuff. You know.
Why not?
Except for funerals, and we don't want to go there.
Okay, let's do that. Let's do it. Just something that Italian that no one will understand. I love that.
I don't know. Ritorno vincitor.
What was it? Did you know?
I would come back victoriously.
Are you serious?
Yes.
For the dead person?
No! Well, yeah, no. No, in opera, they never really die. They just keep on singing.
Okay. I love that. Okay, once in a while we'll interrupt with something, if you feel comfortable, with something with opera. By the way, first time I have shoes, that shoelace is the color that I like the most.
I was going to say, you're a very color-coordinated person now. So you've become very stylish, way beyond my pathetic standard.
It was just random today. Okay. Now, once I think that there was some things that I remember about Mark's involvement. One, there was Neptune controversy.
Pluto controversy.
Neptune lovely. Controversy. He's listening. Pluto, you know, the smallest, basically, planet, well, planet in quote, around the sun. And he was in the middle of that controversy. These scientists...
Still am?
Yeah, still continues. You know, in logic, we talk about definition of words, whether it is prescriptive, or conventional and descriptive. This one seems kind of between descriptive, prescriptive. No, not descriptive.
Well, no, it's descriptive, and that depending on how you define it.
You're right.
So if you say that, you know, like I define planets as being things that are round from their gravity, and that orbit the sun, and that's about it. Because it turns out that when something is that massive that it gets round, that's when geology turns on. And that's what we're interested in studying. Exactly.
And what is your definition? Your definition is more physical, objective definition, based on the structure of the matter, the gravity involved in the center. And by this way you say, well, who cares if it is a dwarf, small, we will not discriminate against them.
That's right. I'm a very non-discriminatory
Non-discriminatory. You make one good definition that even an idiot can understand.
And you can apply it to objects around other stars.
Exactly.
Whereas there's other definitions that it's more difficult to apply to objects around other stars because if it depends on what other things are doing around you.
And what is the opponent's argument? We are talking about Pluto. If you have fish memory about Pluto.
Challenge authority. Always challenge authority.
He is the one.
Well, yeah, the International Astronomical Union definition is that planets are things that are large enough to have swept out their orbits from of other material over the age of the solar system. Okay. And so how do you know that's happened? You know, so if you look at another star, how long has it been? How old is it? How can you, if you can barely see any planets around the other star, how can you see if there's debris in their orbits? How can you tell that it's accomplished that? It becomes very hard, you know, whereas you can kind of get an idea of how big something is. And from that you can calculate what the mass is and if it's big enough to, you know, be a planet by what I call the geophysical definition. So, you know, so it's just easy, it's more extensible. And plus, you know, we make definitions to try to organize our thinking about something.
Categorize.
You know, focus our.
It should be clearer. You prefer clarity.
It needs to be useful. Useful. And if we, so for Pluto, I like a definition where it's about the characteristics of the object, not about its effect on other things. Because when we send expensive spacecraft out into different parts of the solar system, we're doing it to understand what's the nature of these objects that we're going to, not what's going on over there?
Yeah,
we're studying here.
Focus
and so if we want to find the right targets to go here, then then it helps to have the definitions that are consistent with that.
Okay, and also I think there was another mission. Some of those ideas comes like fiction in your minds. Oh, we should do this and stuff. Some of them may have merit. Some of them not so. Well, it is. It is the game.
Sure.
You throw the net. Always, you don't get the same number of fish.
Sometimes you get a fish you weren't expecting.
Yes. And you become the
Which
fish.
is good. Yeah, right. Depending on how you throw the net. So.
Okay. The other one was about asteroids. Asteroids going extracting mineral or finding some exotic stuff there. What was it?
Well, for a long time, off and on, I've been involved with the idea of using asteroid resources to help support our activity in space. So for instance, if you can identify asteroids that are easy to get to, and there's a lot of asteroids that are much easier to get to than the surface of the moon. It takes less energy because the moon has gravity. You get one of these objects, and if you could find water or material that you could heat up and get water off it and bring that water back and use it for rocket fuel. Then, if you only needed to bring up
Water, you mean ice, basically?
Water.
Ice, yeah.
Well, ice, or it could be like clay that has water in it. You could take it off. You could extract it, and you could break it in hydrogen and oxygen and use it for fuel. And if you don't have to, if all you have to do is bring a spacecraft up to low Earth orbit, and then you use fuel from up there to go wherever else you want to go, then suddenly it's much easier to get around and do things in space. But it's got to be economical. I mean, you don't just spend $1 trillion and go do something. You gotta. It's a stepwise process.
Maybe in the future it could be some feasibility or.
Oh, we could be taking the steps today if we wanted.
Okay, since you said space, we through our consumerist and system, we have polluted our land and the sea and the sky, correct? The atmosphere, we have a lot of pollution. Now, I think you are involved in polluting the space, correct?
Well,
with how many?
It's a better place to pollute. I'll tell you.
No, I mean not very far space. I read there are a lot of junk material
yeah. We're always
satellites,
worried about space debris. Yes,
space debris.
When we blow up satellites, the garbage doesn't just go away. It stays orbiting and represents a hazard to other satellites and things whose path it might cross. And so that's a great big international issue because the satellites we put up there are expensive. And if they take space station is expensive. If suddenly it's being threatened by garbage, that's not good.
And it is tragedy of commons out there.
Yes, and so so there's been a lot of effort over the years to come to international agreements so that when you say launch a rocket, the stages that go up, that they end up back in the Earth's atmosphere and burn up. So they don't just end up and break up and then start making things worse. And there's all kinds of effort where people are trying to come up with ways of how do you clean it up. It's not easy because it's a huge volume. So over the history of the space age, this wasn't something that people thought about initially because it was new. But today we worry about that.
Okay. Now, Buckmaster showed up. Anyway, now I want to. Through this,
don't hurt.
Yeah, I want through this to.
It's got coffee in it.
Coffee in it. No, okay, I will not through this one.
Thank you. Thank you.
There was some coffee there. I want to through this.
You can't take him anywhere.
I want through this to the sky.
No.
I want it not to come back.
Yeah.
How much initial velocity I need to give to this one? Do you remember the number?
Yeah, it's about 6 kilometers, 7 kilometers a second.
No, 11. I thought 11.
Kilometers, miles a second, yeah.
Yeah.
So
Oh, you're right. Yeah,
6-7
it
miles,
was 11.
miles per second.
I think you're in kilometers.
Yeah, I'm a
but
scientist, but I don't keep everything up here.
I know. I don't even expect that. I don't know. I remember check it with Professor Google. What is the escape velocity? It is right. It's called escape velocity.
Right.
Means something from here you are throwing up, it will come back, but there is a certain velocity, means speed with direction, you need to
11
give
kilometers
it.
a second. 11.2 kilometers a second.
11.2 kilometers per second. With such a power, if you throw up, it will stay there, will not come back. Very good, interesting. Okay. Now, tell us about what you are doing now. What are the projects or challenges regarding your institution? Not something very dull, you know, there are children who will be listening, and there are very well educated.
The children, the parents want it to be dull. They're too excited.
Okay.
So, I'm involved on a mission, the Dawn mission,
Okay.
which we spent a year at the second largest asteroid, Vesta, which is kind of a rocky body, and but the size of Arizona. And
wow.
Now we're on our way to, and we found a lot of really.
Where is it? Where is it?
It's in the asteroid belt between Mars and Jupiter.
Oh, Mars, Jupiter,
And,
far away from us. Thank God.
Yeah, but now we're on our way to the largest object in the asteroid belt, Ceres, which is also a dwarf planet.
Okay.
You know, and the cool thing about Ceres is that it formed with a lot of ice as well as rock, and we think that it's possible that it might have a subsurface ocean beneath its surface, and it's about the size of Texas. And the cool thing about that is that if there's been liquid water over the age of the solar system under the surface, could there be life today? And so one of the things we're going to be looking for is evidence of this water. Now, we can't drill down. We're only orbiting, you know, we're only going to be orbiting and looking and see what we can see. And but if Ceres is very dark, has a very dark surface, like the back of this book. You know, it's about 9%, only reflects about 9% of the light. But if water's coming up from
dark, it's made of what material?
Carbonaceous type stuff. You know, stuff with carbon in it. You know.
Really? Maybe oxidated steel.
No.
Really?
It'd be more like
Lighter material.
Yeah, much lighter material. And so if there's water that's kind of leaking up to the surface, and then of course it's vacuum, right? So it evaporates right away. But it's likely to be very heavily mineralized. And what happens when you evaporate heavily mineralized water? You have a slag left behind of evaporites that, like the stuff you see around geysers, white stuff. And so if we see these white splotches on this dark surface,
your interpretation could be geyser.
Or just water. There's water coming up and evaporating. And the thing is that over time, there's meteorites that come in and hit the surface all the time, and that mixes it up. And it takes a very small amount of dark material mixed with white material to make it black. And so if you see something white, it's fresh coming out from the surface. So that'll be the smoking gun. So I'm going to be looking for that. And it's also going to be weird because it doesn't, because it's got kind of an ice-rich mantle, you know, outer layer. The craters near the equator are going to relax over time, and so it should be relatively flat surface until you get up towards the colder poles, where things are cold and hard enough to retain more of their crater shape. It's going to be a very weird-looking place, and I'm expecting that when the craters relax, then we'll see. It won't be just nothing. We'll see like these spots on the surface, which are called at some other places in the solar, they're called palimpsests. I'm going to call them blims for blemish. You know, it's a ground blemish, but call it blim for short.
Okay. And what about Mars mission? Were you involved in Mars mission in the past?
No, but we were involved. But our scientists here are involved with all the Mars missions.
Okay.
The Curiosity that's rolling around right now, and one of the MERS, one of those smaller rovers that are roving around there, and they've been finding evidence for you know, old stream beds and things like that.
But no water so far.
Well, water's been seen now, you know, on Mars. There's seasonal water in some craters where at certain times of the year, liquid water starts flowing down the crater.
But is it analyzed? Vision is different because there is a lot of possibility of error.
Not much. Well, I mean, it's pretty clear that it's liquid water. But you know, if you could scoop it up and see if there's any bugs in it, we haven't sent anything down there to do that yet. So hopefully we will. That'd be cool.
Since you are talking about life, and you know, the universe we're living is really not very friendly for life, very hostile. Most of the 99.9999% is hostile.
Oh, well.
Either very, very cold.
You don't cut enough slack. I mean, come on. I mean, we have all these, you know, billions and billions, trillions of stars.
And
you know,
now
the
they
galaxy.
have planets.
Most of them have planets, and a significant fraction of those may be planets where you could have liquid water at the surface where it might be actually fairly friendly to life like we have life. Okay. And so, you know, and then, so there could be millions of places in the in our own galaxy, in just this galaxy, where life could exist.
Yeah.
So and if these places like Ceres, you know, starting with the subsurface ocean, those kinds of small icy planets that with the subsurface oceans, they may be the most common kind of planet in the galaxy. And if in these oceans you've got life forming in there, say microbial life of some kind over the age of whatever solar system, that I kind of look at these things as potential incubators, such that then you know, because there's things always stirring the solar systems. You know, in our own solar system, the early solar system, the Earth and Moon were bombarded, you know, because the Jupiter was moving and Saturn was moving, and it was causing lots of things, lots of small bodies to get kicked around, including the dwarf planets and such. And so if a dwarf planet like Ceres could very likely have hit the Earth early on in its history, brought in a lot of water, and maybe also contaminated the surface with life. And since Earth is in that nice Goldilocks zone, that life could have taken off and become more complex over time to even you and me. But so given if these kinds of small incubator planets are the most common in the galaxy, then all they need is a big guy in a habitable zone to run into at one time or another, and it could infect it. Yep. And so you know, we don't know yet, but we're beginning to understand some of the parts of the old Drake equation. You know, how many stars have planets? How many planets are
the Drake equation to me has no value.
No, it helps.
All unknowns.
No, but some of it's becoming known now.
Oh, okay.
And so I'm saying that some of those. So maybe we're going to start zeroing in on just how common life in the galaxy is. I am open to zero or a large number.
Well, if it is not zero, perhaps it is much more. It seems kind of my expectation there will be a lot of life forms, different.
I remember back in 1996.
Yeah.
You know, here in Tucson we had this conference that I was one of the organizers of all the planetary scientists in the country came to Tucson.
Yeah.
And it was a big year because you might remember the Martian microfossils. You know, they thought they saw bugs inside of a meteorite that was picked up in Antarctica. So there was, you know, it was controversial, but it actually still is controversial. It's not like completely zero or whatever, but so that was very exciting. It was the year that the first planets around another star was discovered that didn't go away when somebody else looked at it. And it was also the year...
Yeah, it was pretty new. In the past, we didn't have any evidence that other solar systems would have any planets.
And then there was the discovery that Europa, Jupiter, one of Jupiter's Galilean satellites, one of its large satellites, had a subsurface ocean. All this, and so the theme of the meeting here in town was life, and kind of the thought at the time, because all this was happening so quickly, was that could life be common everywhere? I mean, it was the prospect that was even a possibility.
Why? We have so much life on this Earth. We have more human than really we need.
Let's eat it. No, but it's like, it's good to see what's out there.
Yeah, curiosity.
You know? Oh, absolutely, absolutely. Well, and it might be our future, you know, because you're talking about how we're not taking care of where we're living.
Yeah.
And you know, I think that there's a reason for maybe looking to see to what extent we might be able to find another basket to put our eggs in.
Oh, yeah, rich people and politicians who declare wars, nuclear war, they will escape there. We'll end up staying here.
Yeah, really. Well, you know, we're worried about asteroids hitting the Earth, right?
Bushra, are you paying attention? Is it recording? Good.
You worry about asteroids hitting the Earth, right?
Yes.
Congress has told NASA, you got to find everything down to 140 meters diameter, you know, or 90% and all that. Why? Why do they care?
Yeah.
You know, well, it's because of survival. You know, because it could be economically disruptive. Look what happened at Chelyabinsk, and that was a much smaller.
Well, initially, go back in 1960s or even 50s, when 57 the space age started, and people would question, why go there? Why go there? Well, now we have our phones all through satellites, correct? You know, it created the technology which we are using.
Right, but that's not why we did it.
I know, but it was byproduct. Therefore, there is always some.
But I remember back at that time, you know, my thinking was that, my gosh, it was the exciting thing was not that we were going to beat the Russians, but the exciting thing was that it was the dawn of the space age, and that we'd all be living and working out in space. It was like going to happen. Okay.
I was born in that year, in 1957.
Huh.
Yes.
Oh, I'm much older than you. I was born in '55.
Very good. Okay, let's talk about food a little bit.
Food.
What's your favorite food? Since
all of
you
it.
go around the world, we'll come back to a few other things I have.
Yeah, food. You know,
cosmology.
I like food.
Well, you don't need to say it.
Yeah, no, I demonstrate it. I like experimenting with food. I was doing things like making fresh blueberry stuff to go with chicken, you know, and combining.
Chicken.
You know, I like to. You know, imagine this: a dish like an omelet with you know, turkeys and strawberries and jalapenos. You know, they're nice complementary flavors.
You have no idea. This guy is not normal. He's one of the crazy guy. You have your picture with your sisters. You have them here. The ones that in airport they come to. He's Irish.
No. Well, I got Irish. I got Scottish.
Scottish, yes, Scottish.
German. So.
They wear skirts.
Kilts.
Kilts.
Yeah, in fact, well, see, unfortunately, I only have a picture on this. It wouldn't be very...
we can show this one too.
Really?
Find it, yes.
Yeah.
Lovely.
Or actually, no, I'd have to do it on Facebook.
Okay, let's go. Find Facebook. While he's finding Facebook, and this is his son. Wow.
Matthew, yeah, and Matthew and his wife.
Wow, Matthew and his wife. He's grown, this little kid.
Yeah.
Beautiful. He became a scientist.
In May he should be getting his Ph.D.
Yep.
Oh, here we go. So here's the real me.
Ah, look at this. This is a cottage.
It's the MacLean of Duart.
I wish you had some in orchestra. Do you have any of your pictures?
Oh yeah.
Chorus, you say?
Yeah. Let's see. Where's one from chorus?
Yeah.
Go back here and find something from.
Have some.
Oh yeah, here we go. Here.
Okay.
Here's me right there.
Oh, okay. Do you see?
1 minute.
This is Mark.
See, that's the real me. You know,
Yeah.
it's just. That was from Lucia di Lammermoor.
Lucia?
Lucia. Yeah.
Okay. Yeah.
So no,
They're all sad stories. Someone dies in those stories, correct? Usually.
Well, you know, I like to say it's not the music, it's the body count. Oh yeah, he gods. Yeah, here I am there.
Oh my gosh, they show that one too.
Yeah, so go back.
Which one?
See, here's a whole crowd of us. See, I sing in the chorus. I sing with a lot of people.
Do you focus?
There I am right there.
Oh my gosh, this guy, can you imagine? This is the head of Planetary Science Institute, this guy.
It's a lot of fun.
That's good.
I mean, you go out on stage and you scream in Italian for a few hours, you just feel better.
Yes. Okay, now let's talk about a little bit cosmology, which is not your much more interest.
Yeah.
Yeah.
I'm more the hood. The solar system. But you know, yeah, cosmology.
Yeah, it is going crazy, you know. There's new theories about multiple universes and...
No, that's not so much cosmology, but
it's not cosmology.
Yeah.
It is.
But I don't really, I can't speak to that.
Yeah. You want something that really, through telescope and microscope, and you can...
Well, I mean, you can see the Big Bang, you know, the microwave emission from that, you know, and the whole sky, and of course people are finding patterns and stuff in it, and that's very interesting to read about, but I don't study it, so I'm not that versed in being able to talk about it.
Okay, what about your heroes? Heroes, let me say, or some figures in history that you are fascinated by them? Not necessarily scientists, could be scientists. Who comes to your mind that...
Oh boy. You ask these tough questions.
So,
you know, I'm interested in history, but nobody is really iconic to me. You know, there's people I'd like to learn more about.
I like Jefferson, for example, his philosophical mind.
Fascinating. Adams, you know,
Franklin,
and even Washington, you know,
yeah.
For the things he didn't do. No, really. I mean, he was he executed his presidency with remarkable restraint. Mm-hmm. You know, and so
yeah, he could become a dictator.
Yeah, he could have. He could have. But yeah, all those political figures are fascinating, and it was a fascinating time in American history that they were all there at the same time. And but you know, and all throughout history, I think it's notable that individuals do count. You know, and that's where I think that some historical models where you have the historical flow and there's some inevitability to whatever that. I think there is some flow, but it can be diverted by the actions of individuals.
Yeah.
And that are able to engage, you know, the populace, you know, at the times to change directions. You know, so yeah.
What about scientists?
Oh, well, I mean, this is terrible that I don't have people that just you know, come to mind. You know, there's you look at somebody like Einstein, of course, with his revolutionary theories, but he stood on the shoulders of other people like Maxwell and Planck. Yeah. And you know, I mean, could there have been an Einstein without a Planck? You know, so
of course, it's accumulation of knowledge.
Exactly.
Meanwhile, also at the same time, also they get ideas from each other.
I think that we often make the mistake of thinking that somehow people come fully formed as geniuses with ideas that they spew out, but it really does build on the work of others. Same with musicians and people. You know, I remember when I was in music school that Amadeus was out at that time about Mozart, and the thought was that, gee, he just sat down and wrote final masterpieces. Yep. No, he didn't. Yep. His wife actually burned a lot of his notebooks and stuff in order to promote the myth of his genius writing out final stuff. He worked on this. He worked on things. He was a craftsman. Sweat, yeah. I mean, genius, but not without sweat. Yeah. So, and the same with science, with everything that we do. That you know, a lot of the work that we do here, a lot of work that I've done it's incremental.
Good. Here is a question for you guys. You are using internet, which internet is a really major invention in history. In the future, it will be a landmark.
And don't believe everything that you see on the internet or read.
Exactly.
You have to be very critical.
Exactly. Well, in that regard, let me tell you something. But first, let me say internet. Now, who invented internet? Of course, there may not be one single person, but there is a guy. Huh? who did World Wide Web, and the internet was started in 1950s, basically. And then, initially, as ARPANET.
Yeah, I think that was more like in the 70s.
Really?
The ARPANET. I was on ARPANET for
Really? No, I think in 50s. Anyway.
We'll have to Google it.
Yeah, we have to ask internet. But who is the one who really contributed to today's internet, mostly in the beginning? We don't know the name of the guy. I read it a few days ago, I forgot. A lot of incredible minds that really we don't know their names, but we know the names of these actors, and frivolous stuff.
Well, the important things, yes. But you know, but the thing about the I don't want to say danger, that's too strong of a word, but because we have so much information at our fingertips, you know, through the internet, it's even more important to be critical thinking, and that's not, by critical I don't mean, oh, I don't like you, but rather just think about, is this reasonable? Does it make sense?
Exactly.
I have a little story.
I have another big story.
Okay, well, I'll start a little story, then you do the big story.
Okay.
The little story is that I was just looking up a technical thing, you know, how there's some asteroids that are bright, some asteroids that are dark, and there's a certain class of asteroids called C for carbonaceous that have an albedo, that's a measure of how dark they are, the fraction of light that they reflect. You know, and I thought, okay, I looked up what's that?
Bring it closer. Yes. Perhaps. The sound-wise, why I didn't think about this? Too late.
Too late. Oh well. Go back.
You're right.
I looked up, you know, what's the fraction of light that they reflect, and I was getting 4% when I Googled it. I thought, that's not right. It's 6%, you know, but I kept seeing 4%. I looked at different sites, it said 4%. And I said, okay, that can't be right. And I went to the NASA Planetary Data System, where they have lists of the reflectivity of all the different asteroids of different types. And so I took all the ones I received, and I added the numbers together and averaged them, and I get 4%. And I said, that's not right.
Wow.
You know, and I looked at the individual numbers, and I said, aha. Not all the asteroids have values, and when they didn't have values, instead of putting in 0.04 or 0.03 or 0.10, they put in minus 9.99 for a missing constant value. When you add it all up, you get 4%. If you take out all those minus 9.99s and average it together, you get 6%. So somebody had just at some point in the past added all those numbers together, got a number that was dark, but it wasn't quite right, and that number propagated.
Exactly, everyone copied the same.
Yes,
very.
So you got to be critical.
Exactly. Here is my example. Very good example.
If you don't think that something seems quite right, don't just accept it. Poke at it a bit.
Be critical, and also you need to have some basic ideas also beforehand.
Yeah. Oh yeah.
Jump
Yeah.
into it.
Right.
And this one years ago, about 10 years ago, I was teaching some classes at my son, younger son, Metin, at his school. And that time I wanted to check, because I found something interesting. I wanted to check teachers. I was teaching also internet research class. The tricks, the common sense you need to that. Okay, I said, teachers, here is the assignment. Find the heaviest element. The number of the heaviest element. Guess what? Almost all of them, they got bureaucratium, governmentium as the heaviest element. 400 something, the atomic number. You cannot believe it, one of them, chemistry teacher. If I was the principal, I would fire him. Now, governmentium, it is an irony, it is a joke. Honey, government is so heavy, bureaucracy, too many levels of bureaucracy. And they made this joke, here it is a heavy element, heaviest element was discovered. It is called governmentium.
I love it.
And very good description.
I love it.
But I think recently, Google is tinkering with the kind of formula to find it. I don't see it as I used to see it. Heaviest element, that time when you check it, the first time comes, it is the governmentium. And they fault it. Yeah. Therefore, you need to really be wise.
Yeah, but never knows really unobtainium. Or administratium. So that could be also.
Oh, I think one of them was another. They have several names. One of the
Oh God.
Okay.
Yeah. But you're right. Also, it is to acquire general knowledge through reading other primary sources, books and things, what you learn in school, and then you take that with you when you go out into that broader commons of the internet.
Yeah, not many books are read. I think through this so much information out there, we thought it will be helpful, but you have so much time, limited attention span. A lot of people, they can basically read one sentence barely. I think Twitter found the average 145
Are you on
characters.
Twitter?
Yes.
I'm on Twitter too.
Really?
Yes. I've got like I told my wife I've got 350 followers. I'm a cult.
I have about 15,000.
Oh God! Oh, okay, well, you're better than me. You're a bigger twit than I am.
No, really. It is not. But yeah.
I do Twitter primarily for doing commentary on real time events with space stuff. Usually
I need
kind
to
of
follow
political
you.
stuff.
But I limit my the ones I follow with 19. Too many you cannot follow. I said that number is a good number. Sometimes I eliminate one, put another one. I follow only 19.
Yeah, I'll do it like if I'm at a meeting and we're having a NASA night. So we got the bureaucrats up there, the leaders of the solar system from NASA up there, and they're interacting with the audience. And I'll be twittering about what they're saying, or they get to do a town hall. I'll Twitter about that. And I've actually gotten a comment that you're twittering faster than I can read.
Twitter, you should not be using too many because
yes.
Oh really?
Oh,
Are
yeah.
you tweeting too many?
Oh no, because I'm asking questions. So, well, what about this? And I'm making a comment.
It's not tweeting. It's chatting. It's no more tweeting.
Yeah, I'm giving commentary while things are going on, and it really irritates some people.
Oh, irritate because then I will drop you to be your follower.
Well, no, they don't. The people who I'm making commentary about, they're not too happy.
I see.
Some people, some government officials don't like to be criticized.
Now, can you show us some funny stuff, interesting stuff here before we leave?
Oh, well.
And, yeah, you can take in your hand, unplug it.
Well, as in most boring offices, this is there's lots of books and things around
beautiful.
Here.
And you have mugs from all over the world.
I have mugs. I've got a plaque which I need to get to the Air and Space Museum. Faith Vilas, one of our scientists, got checked out in a seaplane a year ago, and flew across Lake Michigan on the 100th anniversary of her grandfather doing the same thing. He was one of the early aviators.
Wow!
And so we got to get his, and they have the whole of his seaplane at the Smithsonian, and so I wanted to add that to that. And now up at the top shelf, you see a whole bunch of CDs.
Oh,
those are some of the first CDs that were ever made. They've got like gold foil.
Oh, really?
They the blanks at the time cost $40 a piece.
Are you serious?
The CD writer that I used cost $14,000.
No way!
Yes.
And why you are having them, so many of them?
Well, because this is one of 2 copies of the raw data of the infrared astronomical satellite. This flew back in 1983. I did this in the later 80s.
Okay, keep it. This is for museum stuff now.
No, it's a data I can use, for science. But the thing was that when I was analyzing this data, I discovered orbital debris. Which is what we're talking about, orbital debris, in the images of the sky that the satellite was taken, and the military freaked out because they thought you could see satellites, and so I was actually banned from accessing this data for several years, and then when they wanted to create this data product of the raw data, then I was allowed access to it again because it turned, well, that's another story. And so I helped design, and then I made 2 copies, one for them, one for me.
Lovely. Lovely.
And,
these are beautiful. Down.
Don cup. And
Surth, whatever it is.
Which became Spitzer. And I have my warrior nieces. I have a lot of nieces.
UPL, jet propulsion.
Yes, yeah.
And okay, go ahead.
I have pictures of my nieces.
Oh, this is picture of nieces. They're all in military.
Army. The young one over there is a cadet at the Air Force Academy. And this is, you've heard of OSIRIS-REx.
Yes.
The mission that's being built at the University of Arizona.
Yes.
It's going to go to this object.
Come on, cannot be something, a little rock rotating around another rock?
Yeah, it's a satellite.
It is not a planet according to your definition. It's not round enough.
It's an asteroid. It's like bigger than this room.
I can't believe this. Are you serious? Something rotating around this?
Yeah. It's got a little
and who
satellite.
are these guys?
These are two of the founders of PSI who are still here. Don Davis and Bill Hartman. They came up with the modern theory of the origin of the moon.
Okay.
They had
Really?
Which was that early in the solar system, a Mars-sized object
Something
came in and hit the Earth, and the debris that came out of it formed
the moon.
And
is it still?
It's still the main theory.
What is Icarus?
Oh, that's a journal for planetary scientists.
And this is by monthly? No, not this. Is
yes,
annual.
it's a monthly.
Monthly. Okay.
Yeah.
Wow, monthly. Look at this. Every month they print this. Too heavy.
And then this is a model of the spacecraft that I'm a co-investigator on the mission.
Oh.
This is the Dawn spacecraft. We spent a year at Ceres, or at Vesta. I'm sorry that it doesn't look like that, but this was a painting by Bill Hartman, one of the guys over here, one of our founders, who's also an artist. And this is actually a part of a meteorite called Milbalilli, which we think came from Vesta. And so you see it's got a much brighter surface, and it's basaltic. And so it's made out of like the stuff we get at the bottom of oceans.
Okay. And this will be basically, the energy will be solar energy, correct?
The energy that powers the spacecraft is solar energy, and then it's got an ion drive that pushes it.
Okay. This is crazy sisters.
No, this is my nieces.
Her nieces.
This is my
his
two
nieces.
of my nieces.
I'm in Turkish mode. His nieces.
Yeah. Yeah, see, this is what my nieces look like.
Lovely. Okay, that's good. Okay.
Yeah.
And well, we don't need to walk in the building. Take this picture of this beautiful ship, whatever it is.
Oh, well, this is our ATSA project.
What is it?
This is
not this one. This one.
This is if you can come on over here. Yeah. This is Next Core Links. It's a space plane which goes up 100 kilometers into space, and then comes back down, lands on the field that it took off from, and would have a telescope on the back of it. It's a two-seater. It's PSI scientist sits over here, the pilot sits over there, and we operate the telescope for 5 minutes above the atmosphere like a sounding rocket.
What is the possibility of realization of this project?
Well, we built the flight camera that'll go for testing in here. They're building this space plane right now.
Do you have budget for it?
No. I'm looking to raising money for our first flights. Okay. So,
but you are involved in private enterprises, seems.
Oh yeah.
Because you have some stuff there.
Right, and we just bought a building across the way, which I have to give you a tour of. I hope we have time.
Yes.
Where we hope to build our training facility. You know, and laboratory for building that telescope, and training so that people could train for sitting in here and operating the telescope during these missions.
Okay.
And so
we want to cut it here. We want to go below 1 hour.
Okay.
And more than that, it will be kind of scary psychologically.
We could talk for a long time.
Yes. Next time we'll have another sequel of this one. That time I will prepare myself. Tough questions.
I'll have to be evasive.
Okay. Can you finish with crescendo?
No.
That's
you have to just make do with my speaking voice, such as it is.
Thank you very much for your patience if you listen, and I hope that it creates some curiosity about solar system, about the universe we live in sciences, Thank you very much. See you next time.
Oh, what a riot. Okay, there.
Okay, we are ready.
Are we ever really ready?
Love it.
Oh.
I like that background noise. You have some surprise questions, if I don't forget them, because
no, you've got the surprise question. I'm just here going, oh,
I didn't take notes yet.
oh.
Look at it, Juris Doctor next to philosophy, which is Doctor of Philosophy means in with science.
Yeah.
Which one is it? Is
Doctor of Philosophy, that's for my planetary science.
Planetary Science. Okay, we need to turn that off. Okay, these phones will not let us. Fantastic. Can you turn it off, please, Lütfen?
What is Islam? What are the sources of Islam? What are the sources of Islam? What is Islam?
Burada sen iş al.
Nereye? Gidiyorum.